All right, so here we go with the review sheet. This is a log function with the base 2 here. So the equation of the horizontal asymptote. Log functions do not have horizontal asymptotes. They only have vertical asymptotes. So this is none. So the vertical asymptote is going to be right here. Because remember that a log function starts off basically looking like this. It comes right through there, has an asymptote of x equals 0. Right? And so if you move right or left, it moves with it. So that would be -4. The domain is everything from -4 over to the right, because it starts basically everything from -4 over, but not including -4. The range, it's going up and down forever, everywhere. So all real numbers. The y-intercept, I see it here at 2. Also can be found by plugging in a 0 right here. So log base 2 of 4. So this is asking you 2 to what power makes 4? Well, 2 to the 2 equals 4. So that's why the answer is 2. The x-intercept you're going to get by looking at the picture, -3. As x goes to -4, so when the graph comes to -4, the graph goes down. And when you go to the right, the graph travels up. Okay. So moving along, the next one is an exponential function. So an exponential function, you are going to have a horizontal asymptote. This is a growth problem. So growth usually looks like this and has a horizontal asymptote at y equals 0. So when you have a horizontal asymptote at 0 and you move down 3, oops, this is a 4, isn't it? You move down 4, then that's where your horizontal asymptote is now. The vertical asymptote, there isn't one. Domain, it goes left and right forever. The range, though, it goes up forever, but it doesn't go down past that horizontal asymptote, -4. So -4 to infinity. Y-intercept is at -3. I put a 0 here. 2 to the 0 is 1. 1 minus 4 is -3. My x-intercept is over here at 2. As I go to the left, the graph is going to -4. As I go to the right, it's going up to infinity. All right, for number 3, it says to solve these equations here. So on number 3, to solve these equations, 3 is a base over here. 3 to the 4th is 81, so I'm going to use that fact. So 3 to the x plus 5 equals 3 to the 4th to the x. So that means I have 3 to the 4x equals 3 to the x plus 5. So I can drop the 3's and take x plus 5, set it equal to 4x. Okay. Take away x from both sides, so I get 5 equals 3x. So my answer will be 5 over 3. On letter B, I'm going to have to clean this up before I start thinking about this. Let me add 3 to both sides. So 16 equals 2 to the 2x minus 6. Well, 16 is really 2 to the 4th. So 2 to the 4th is 2 to the 2x minus 6. So cross these 2's off. 4 equals 2x minus 6. Add 6. And divide. All right. Over here, remember we're just going to change this log to an exponent. But before we do that, we have to get rid of anything on the outside. So like this -2 being multiplied, I have to divide that out. If there was anything after the parentheses, added or subtracted, I'd have to get rid of it. So I divide both sides by -2. So that means I have log base 3 of x plus 7 equals to 4. Well, now let's write it as an exponent. 3 to the 4th, remember it goes like that. 3 to the 4th equals x plus 7. So that's 81 equals x plus 7. And take away 7, that would get me 74. All right, back side. So asymptotes, horizontal and vertical asymptote for our rational functions from last chapter. My denominator is going to be my vertical asymptote here because there's no cancellation possible, so x equals 5 is the bad number. Here I have to factor. The top factors into 2x plus 3 and 2x minus 3. Those are perfect squares. The denominator is x plus 2 and x minus 2. So no cancellation. That means my vertical asymptotes are at plus or minus 2. Over here, I can take a 2 out and leaves me with x minus 2. In the denominator, what multiplies a 4 and makes 3? X minus 4 and x plus 1. No cancellation, so my asymptotes are at 4 and negative 1. My horizontal asymptote are controlled, remember, by the exponents. So these right here are matching exponents. So I take the leading coefficients, 2 over 1. So horizontal asymptote is 2. All right, my exponents here are x squared and x squared. So again, matching. So 4 over 1 is 4. In this problem, I have a 2x and I have an x squared. So this is a mismatch. The top is smaller than the bottom. So that's automatically asymptote of 0. Y equals 0. All right. Explicit formula. This is, so make sure you have your formula sheet. My formula, this is a multiplication by 4. So my formula is this. All right, I'm just going to fill in A1 and R. It's multiplying by 3. So my formula is going to be 3. I'm sorry, multiplying by 4. 4 to the n minus 1. Determine my 8th term. So that means I'm just going to be plugging 8 into this formula. So 3 times 4 to the 8 minus 1 is 7. So you pop that in your calculator. And there's your answer for that one. All right, down here, the sum of the first 10 terms, you got our sum formula is A1, 1 minus r to the n over 1 minus r. So I have to fill that in, so I make a fraction. My first term is 3. 1 minus r is 4, remember. To the power, oopsie, 10. Close that parentheses. And the bottom, 1 minus 3, 4. Okay, and there is your answer. Okay, over here. This was not geometric, this was arithmetic. So this was adding 7 every time, right? Yes. So the explicit formula is going to look like this. A1 plus n minus 1 times d. So let's see, that would get me negative 8 plus n minus 1, my d is 7. So when I work that out, I get negative 8 plus 7n minus 7. So my final answer is 7n minus 15. Then if I want the 35th term, I just have to plug 35 into here. 7 times 35 minus 15. And there is your 35th term. All right, determine the sum of the first 40 terms. So sum of 40 terms, that means the n over 2. Here's my formula I'm using. A1 plus an. All right, the first term is, 40 things, so 40 over 2. First term is negative 8 plus, and this is the hard part, if I want 40 things, I need the 40th number. I need A40. Well, I already figured out the formula here. So you could plug 40 in here and get that, or you just come back and use this formula. First term plus 40 minus 1 would be 39 times the d value is 7. So I figure that out. Negative 8 plus 39 times 7. So 265. So there's a 265 right here. All right, 40 over 2 is 20. I got negative 8 plus 265. And there's my answer. All right, then the next one is, it says a geometric series. So you can only have a sum to infinity with geometric series. All right, so this is dividing by 3, which is multiplying by 1/3. Remember, if you can't find the r value, you can always take any two numbers and divide them. 4 over 12 is 1/3. My first term is 12. My formula that I'm using is a1 over 1 minus r. I have to make sure that r is between -1 and 1, and it's 1/3, so it is. So my sum to infinity is 12 over 1 minus 1/3. So, let's see, make a fraction. 12, 1 minus, make another fraction. And there's your answer. All right, so in this next problem, it says there's an exponential that's growing exponentially. So we had to put these numbers in our calculator. So remember, press the stat button, go to edit. I already have the numbers in there, but you would, if you was a blank, you'd put them in. If there's already other numbers in there, you go to the top and you press clear and enter, and it clears them out for you. Do not press delete. All right, so I put the numbers in. Then I need to go to stat, over to calculate, and down to 0. 0 is exponential regression. And notice it says those exact words right here. Okay. So I go down to store and I do alpha trace to get y1 and calculate. So here's my equation. 215, so I'll just say 216. My b value, so I'm going to protect that and have a power x. My b value is 1.65, we'll say. Right. All that information, since I told it to store in y1, it's already in there. It's in my y. So I am going to plug in 7. That's what it says to do. So I'm putting a 7 right here, but I'm using y1 to do it. So I do alpha trace to grab y1, parentheses 7. So it's going to plug 7 in, and there's my answer. So 7,259, we'll say, bacteria. Okay, over here. So convert each log to exponential to log. So here's my base. So I'll write log base 4 of 1 over 64 equals -3. Because remember, it has to go like this. 4 to the -3 equals that. So my base is 25. Leave a little space. 25. My power is 1/2. My answer is 5. Okay? And it has to be true here. Remember, 1/2 power means square root. The square root of 25 is 5. Yeah. Right here, base 2 power 4 has to equal 16, and it does. 3 power -3, so it means we're going to flip it over and do third power, so that equals 1 over 27. Okay, let's see here, number 10 and 11. So for number 10, we have a exponential function. This exponential function, it's a growth problem. So it's growing like this. The asymptote was y equals 0. It only has a horizontal asymptote. It does not have a vertical asymptote. So there's been some changes. Right 5, up 3. So moving something right 5 does not affect the asymptote. But moving it up 3, the asymptote has to follow. So this asymptote is now going to be at 3, and the graph's going to be like over here more. Okay? So y equals 3. This number controls it. Right? And then you have a log function. Log functions usually, normally, are right here, have a vertical asymptote of x equals 0. They do not have horizontal asymptotes. So this graph is moved left 1 and down 3. So left 1 puts my asymptote moving, down 3. So the graph is going to be like down here, but the asymptote is what we're interested in. It had to move left 1, so it's controlled by this. Right, and that is it.